Now let's do an introduction to converting NFAs to DFAs. So let's consider this example. The language is W such that W has 101 or 11 as a substring. And the NFA, this is one of the possible NFAs. It's not the only NFA for this language. The NFA that we will look at is this. So you'll have 1, 0, or epsilon, 1, and this is our accept state. And then, so this is one possible NFA. It's not the only NFA. So the NFA or the DFA or the regular expression are never unique. In general, you can have an infinite number of equivalent NFAs or DFAs or regular expressions. OK, so this is an NFA. So what we want to do right now is to trace this NFA on a string to see the different paths in this that are hidden in this NFA. OK, so tracing this NFA on the string, trace the NFA on the string 0, 1, 0, 1, 1, 0. So what happens is that, or let's give the states names. Q0, Q1, Q2, and this is Q3. So let's give them names. So now originally we are in Q0. We are in the start state. Now, if we get a 0, and we are in the start state, what are the options that we have? Yes, staying in Q0. So we have only one option, which is staying in Q0. This is when we get a 0. Now we get a 1. We get a 1 and we are in Q0. How many options do we have?
2.
In fact, 3. So if we have a 1, if we get a 1 and we are in Q0, there are 3 options. The first option is staying in Q0. The second option is going to Q1. What's the third option?
Q2.
Go to Q1, then continue to Q2, because I can continue with an epsilon. Right? So an epsilon can take me from Q1 to Q2. So I have 3 options. So I can either stay in Q0 or go to Q1 or go to Q2. So this means that a 1 can take me from Q0 to either Q0, Q1, or Q2. So what does this mean? It means that my state at this point, if I get a 0 followed by a 1, then my state is this combination of states. This is my current state, which is a combination of states. So I can be with a 0 and 1. I can be in any one of these 3 states, but I can never be in Q3. So these are the only 3 states that I can be in. Now, if after this I get a 0, so with a 0 from Q0 to, with a 0 I get to Q0. Q1, if I get a 0 when I'm in Q1, where do I go? Q2. And if I get a 0 when I'm in Q2, where do I go?
Nowhere.
Nowhere. There is no transition. And no transition is just like implicitly going to a trap state. So a trap state. So this is a dead end. So if you get a 0 and you are in Q2, this is a dead end. So this ends. But luckily, we have other paths. So this path ends here. But we have other paths. Now, Q0, if I'm in Q0 and I'm getting, what's the next? It's 1. I'm Q0 and I get a 1. So the same thing here repeats. So I can go either to Q0, Q1, or Q2. And this is with a 1. And if I get a 1 when I'm in Q2, where do I go?
Q3.
Q3, that's the only. So there's a lot of branching that is going on here. See, we are tracing the processing of this string by this NFA. And we have all of this branching because it's an NFA, and given a symbol, and we are in a given state, we can go to, there may be multiple possibilities for the next state. Okay? But with a DFA, if we trace a DFA, tracing a DFA will always look like what?
Just a single path.
Yeah, it's a single path. Tracing a DFA will always be like this. It's a DFA. You always have one option. If you are in this state, you always have one option. If you have this state and you get this symbol, you only have one option. So when you have one option, you get this. Now, now one of these states is an accept state, which is Q3. Now, what does this mean? What does this mean? It means that this string, which is a substring of the string that I'm trying to trace, this string belongs to the language because here at this point, one of the possible states is an accept state. So one of the possible states that I can be in is an accept state, which means that this string will be accepted. Now, if I continue with a 1, Q0 with a 1 will go to, again, it will branch again. Q0, Q1, Q2, and Q1 with a 1. If I get a 1 when I'm in Q1, what will happen? Nowhere. So this is a dead end. If I get a 1 when I'm in Q2, there is only one option, which is going to Q3. And if I get a 1 when I'm in Q3, where do I go? Q3 again. Okay, and these are accept states. Okay, I think this is, we don't need to do the 0. I think the idea now is clear. We don't have to do the 0. So the idea here is an NFA is encoding a lot more paths than a DFA. In the DFA, there is only a single path for every string. But here, for a single string, I can have this tree of paths. And in terms of the number of possible paths, if this is n, where n is the size of the string, in the worst case, this is what? This is an exponential function of n, depending on the branching factor. So this, whenever we see a tree, that's exponential. So it's an exponential. In the worst case, this is an exponential function of n, which means that I can have a huge number of paths. And even if you look at a single level here, this level consists of a combination of states. So the idea in converting an NFA to a DFA is to view this combination as a single state. So I can redefine this, and I can call this D 0, and I call this D1, and I call this D2. And this is another state, Q0. This is another combination that I call D3. And this is another combination that I call D4. And this is Q0, Q1. This is the same as this. So this is D4 again. So the idea in converting an NFA to a DFA is to look at a combination of states as a single state. So it means that if I am in D1 and I get a 1, I go to D2 because I have renamed this combination of states to D2. So that's going to be a state in the DFA that I will be constructing. And this D3 is going to be a state in the DFA that I will be constructing, and same here. So now, each one of these combinations, I gave it a name. But how many combinations? What's the total number of combinations that I can have?
Oh, I just want to know again, why did you name it D4 twice again?
Because it's the same set of states. 0, 1, 2, 3, 0, 1, 2, 3. So this is a combination or a set. And repeating 3 in the set, it stays the same set. Okay? So in the NFA, I accept if one of the states in this set of possible states is an accept state. Now the question is, how many possible states, how many possible combinations of states can the DFA have in the worst case, the DFA that corresponds to this?